Today, as we are going to apply, notice the misspelling there on yours? Anybody? Yeah. I'm an Apple fan. I accidentally said Apple up there. So please make that change to apply. I know. And yes, I'm a math teacher, and yes, I should be concerned about grammar and spelling. That's not an English thing. That is a life thing. Okay, so I'm going to apply the law of cosines. Now, fortunately for you, the law of cosines is the ugliest thing you've ever seen. So, never mind. So, when do we use these? So, first off, let's recall, for law of sines, we're going to use it in the context of angle, angle, side. We're going to use it in the context of side, side, angle. And we can use it in the context of an angle, side, angle. The reason for this mix, of course, is we need one side and one angle, because we have to create a proportion. We have to create a proportion and also a scale factor. Okay, over here, this is called the law of sines. And there are two contexts in which we're going to use this one, whenever we have side, angle, side pattern, and whenever we have side, side, side pattern. Now, as you look at this, what looks kind of disgusting, your math book is just throwing up here. Here we have an A, and then over here we have an A, and then here we have a B, and over here we have a B, and then over here we have a C, and over here we have a C. So it's a little bit hard at first to tell some things, but as you look at this pattern, so I'll read it first, and then we'll look to see what sort of pattern arises. So here's a side length, A squared, and notice over here is angle A. So that's the angle A that we're dealing with. It's the opposite angle there. So A squared is equal to B squared plus C squared minus 2 times B, C times the cosine of A. Now the next one is very similar. Of course, it's B squared plus A squared plus C squared equal 2AC cosine of B. And next is C squared equals A squared plus B squared minus 2AB cosine of C. What pattern do you notice? Please take a moment with your partner. What patterns do you notice? When we start establishing the pattern here, whatever two sides you use here are the two sides that you use there. And another thing, Robbie? So the next part is that this side is opposite of this angle. So, and every single time, notice everything that doesn't change. Minus 2, there's a cosine, minus 2 cosine, minus 2 cosine. And notice the first part always looks like Pythagorean Theorem. Not necessarily with the A, B's, and C's, but just with the fact something squared equals the sum of two things squared. So this part looks like Pythagorean Theorem, and this part is always negative 2, whatever these two are, and then the opposite angle of the thing that you are isolating. So, all right, let's apply it. So first off, we're going to use the law of sines to find the values. We're going to round our values to the nearest tenth. This pattern here is side, angle, side, as we can see. So it's a valid place to use it. So let's just see what we have here. If I'm trying to find this side, notice I'm not calling it A, B, or C. I don't have to. Notice that it's going to correspond to that 50 right there. So I already can set up a piece of it right now. I have x squared is equal to, and then way over here, at the end, I can say the cosine of 50. So those parts are the corresponding. And I might not have left myself enough room. Next, we know that the sum of the squares are of the other two sides. So 81 squared plus 72 squared. And we also know it's 2 times those two numbers again, 81 times 72. So like I said, at this stage, all of this can go into your calculator, especially if it's like a one that is printing it out as you go. But for now, I'm going to just do the first part here. I'm going to do the sum of the squares real quick here. And then I'm going to put all of this into my calculator and write that down there. So I calculated that, and I do have to change this to estimate or approximately. Now notice I'm still at x squared here. So in my calculator, when I subtract these, then I hit the square root button. So I'm going to do that all in one step. Good, so after I subtract those, take the square root, I get approximately 65.2. So let's go up here to see if that's reasonable. 65.2, which means if I were to use the triangle inequality theorem, that since this is the smallest side, this is going to be the smallest angle. Shortest side, smallest angle. So that could be true. I first thought maybe this one was smaller, but we'll go with that. Now once we have that, 65.2, we don't have to use the law of cosines anymore. Now I have an approximate scale set up here. So now I can use the law of sines and set it up like so. I can say the sine of 50 degrees over the sine of 65.2. I'm going to put an approximate value there because the 65.2 is an approximation. And I'm going to compare it with the 81 and the y. So this would be the sine of y over 81. Now I'm going to cross multiply and inverse sine. Cross multiply and I have to inverse sine. And when I do that, y is approximately 71.1 degrees, which is reasonable because clearly this one is larger, this side is larger, so the angle opposite has to be larger. When I use the triangle sum theorem, I get 57.9-ish right here. And triangle inequality says this is the small angle, small side, medium angle, medium side, large angle, large side. So it does at least fit and seems to be a reasonable answer. Good. Made a clarification error here. It's actually 72.1. Everything else is correct. I just wrote it wrong. So now let's attack, kill, destroy. Notice the context here is side, side, side. So I can't use the law of sines on this one because I can't, if I put only sides down, I would only have all the bottom filled out on the extended fraction proportion. So I definitely need to use my law of cosines on this one. Woo. So let's see here. It doesn't matter where you start, just as long as you call it. If I call this one the angle I'm looking for, then that's going to be the opposite there. And that will be my 15. So I'm going to use that as a reference. I could have chosen y. It was fairly arbitrary. So I'll start with the 15 squared. So if we remember what our pattern goes, like this. Now I'm going to take the other two and square them. So in this case, I will take the 12 and the 18. So the first part looks very much like Pythagorean Theorem. Then always subtract 2. And then the 12 and the 18 show up again, this time not squared, like so. And our last thing is the cosine of the opposite. So here, the cosine of the opposite is my x there. My next step is I just start to simplify everything that I can, and I have to isolate. So notice what I have to get rid of. After I multiply this, I have to subtract it. After I simplify this, I'm going to subtract it. And after I simplify this, I'm going to divide by it. Because look, it's times cosine. So let me just take the next step. All right, so those all simplify here. And now what I'm going to do is I'm going to combine these guys and subtract them at the same time. So combine and subtract from that side. Added those. Subtract it from both sides to get this, and that stays the same. So now I have to divide both sides by the negative 432. By negative 432. And then we get 0.5625 equals the cosine of x. We know we're on the right track because generally speaking, the ratio of cosine will be less than 1. Now what I need to do is inverse cosine on both sides. So I just punch that into my calculator. Now I'm going to repeat that process. I can do that whole process once again. this time using 12 and y as my anchors, I guess, and the other numbers there. Or at this point in time, I can do law of sine. So let me go ahead and set up and do law of sine here. Now the law of sine will give me this proportion. I'm going to fractionize these two and fractionize these two here. I'm not using 18 because I'm not interested in this angle right now. Now I can just punch all this in my calculator. I have to do multiply these, divide this, and then inverse sine. And now we go on to see that after we plug it all in, 41.4 degrees. And of course that does look somewhat 41. Notice that all these won't be to scale, but so far so good. Let's walk through an example of how this works in actual life. One airplane is 78 miles due south of a control tower. Another airplane is 52 miles from the tower at a heading north 38 east. That means 38 degrees east of north. We'll unpack that in just a second. To the nearest tenth of a mile, how far apart are the two airplanes? You might need to draw a diagram first off, and second, your diagram might be wrong, so you might need to erase it. So be prepared for that. So before I even commit to it, I'm just going to sketch it over here real quick. So I have a control tower, and then I have an airplane that's hanging out, it says, directly south of the tower, so I'm going to be down here. And then how do we interpret this part here? Another airplane is 52 miles from the tower at a heading of north 38 east. That is 38 degrees east of north. So watch the magic here. What you have to do is north is a direct vertical line like that. 38 degrees, and notice that east is this way. If you recall, east is that way. So I have to do 38 degrees off of this line. So here's north. So I have to go 38 degrees in this direction, as opposed to 38 degrees in the west direction. Okay, so west is that way. So 38 degrees in this direction. So that means this guy here is down here at 78, and I'll clean up the diagram in a minute. And the other guy is 38 degrees off the north. So that means this angle right here is 38 degrees off the north. And that's 52. Okay, so the question is, how far apart are the two airplanes? So I'm going to re-sketch that over here. So here's my control tower. And directly south is an airplane. And then the other one is up here, and I'm going to draw that reference right there because this angle is the 38 degrees. And the question is, how far are the two airplanes? So there's airplane B. So however are we going to come up with anything about this? I do need to label those, 52 and 78. Oh, is that not drawn to scale? And 52. Not drawn to scale, so I might want to resketch. Notice the 78 should be longer. So just for accuracy, I did make some changes here because I wanted this red 52 to be smaller than the 78. So notice we don't know anything about any angle inside the triangle. We don't know any angle inside the triangle yet, but how do I find this angle right here? Go ahead. Good. They're just going to be supplementary angles. So I can supplement the 38 degrees right there and now find that one. So I get 142 degrees. Notice the question here is the distance between the two. I'm going to label that a small c. You might want to do d for distance, but in this case I'm just do small c because it corresponds with a capital C, which is my control tower. Okay, so now I'm going to set it up. Since I'm looking for that C, I'm going to C square there. And then I'm going to put in the 52 plus the 78. minus the 2, and that's a square, should be, boop, 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 square, minus the 2 times 52 and 78. So, now this is all just simplification, so we can plug all that into your calculator if you want, or go step by step. So after we plug a bunch of stuff into our calculator, I get approximately 123.2 miles away, which is what my expectation was, considering that's 78, that's 52, very large obtuse angle. So I expected this to be under 130, but certainly larger than 78.